So, topic is on confidence interval for population mean. What is an interval? That's an easy question. Did we take algebra? Go ahead.
It's like a range of time or variables or something?
It's a range of values. You may ask me, well, why do we need a range of values? Well, if I have data and I want to find the mean, we have some arbitrary sample, and the sample mean of that particular sample is 24.2. Naturally, the sample came from a population, so if that one sample gave us 24.2, do we expect to get the same 24.2 if we collected a different sample? Why not? Huh?
I said because they're different, or the samples are different.
Right, so if I collected a different sample, of course I'm going to get a different number for the average. But we can't make the argument, oh, let's keep on collecting different samples time and time again for us to come up with an average and get a better idea about that average, because we don't have resources. And that's where theoretical statistics comes into play. And the purpose of a confidence interval is to come up with a range of possible values based on the single sample that you have, and say, well, instead of the average being exactly 24.2 with some probability, which is the confidence, I could say, well, it's somewhere from 20.4 all the way up to 26.2. See the difference? So I'm going to say, okay, I'm 95% confident that the mean is going to lie between this value and that value, which is better than giving a single value. Things to know. The first thing is the confidence level, and textbooks like to call this as C level. The amount of confidence is pretty much the probability in concluding that the population mean will fall in the interval that we will come up with. For instance, consider this interval as an example. So mu is the population mean, and I'm going to say, okay, the population mean is going to be between 1.4 and 2.8. And in getting this interval, I used a confidence level of 95%. We will connect the dots in a bit. So, 95%. How would we interpret this? Well, if I went and collected 100 samples over and over and over again, 95 out of those 100 samples would give me a mean that would lie between 1.4 and 2.8. Does that make sense? So if I repeat the experiment over and over again, say 100 times, 95 out of those 100 times, the actual value of the mean would lie between 1.4 and 2.8. And that is the conclusion. When we say we have an interval with 95% confidence. Are we clear? So that's just the introduction. Now the procedure to find an interval. What is the most important thing that we would need?
The mean.
The mean. Where do you get the mean from?
Because you're talking about, for example, the sample mean is for a sample,
Right, so where would we get the mean from?
the sample.
The sample. So the most important thing is have a sample. Once we have a sample, the next step would be to find the sample mean and the sample standard deviation. That is pretty easy. We've done that multiple times before. So we have the sample, then we have the sample mean, sample standard deviation. The next step would be to choose a confidence level. So there is a thing, well, there is the concept of confidence level, and it is related to something called a significance level. So this is the C level. And the C level is simply 1 minus alpha. But what is alpha? Alpha is the level of significance. When we move on to the next topic, this would actually have an entirely different meaning. But for the time being, the confidence level is 1 minus alpha. If that is the case, what is alpha in terms of the sea level?
The level of significance.
Huh?
The level of significance.
Right, I mean, algebraically, how can I rewrite that equation? If sea level is equal to 1 minus alpha, alpha is equal to sea level plus 1.
Sea level minus 1.
Sea level minus 1.
Oh, 1 minus sea level.
1 minus sea level. It only took 3 attempts. And you may ask me, well, what should that value be? Well, should you pick a level of confidence of, say, 10%? Do you want to make a conclusion with a 10% confidence? No. How about 30? How about 60? How about 90? How about 95? How about 99? 99's okay too. So 90, 95, 99. Most common levels of confidence that we use. And it is quite subjective as to how you should pick that value of alpha. I will not get into all that detail, but the common values of confidence that we use would be 90%, 95%, 99%. Once we have all of those, the next step would be to find the margin of error. And the margin of error is always a product of two things. One, standard error. The other, is a critical value. Standard error has a formula. Critical value, we get it from a distribution. I'll explain that. But you can't forget that the margin of error is always the product of two things, which is standard error and critical value. Good? Now, standard error. That is the formula for standard error, S divided by square root of n. The critical value is a percentile obtained from a t-distribution with degrees of freedom equals n minus 1. Last time I showed you how to find percentiles with a normal distribution. Now it's a different distribution, it is called a t. I'll get into that too. But the key here is the degrees of freedom, which is n minus 1. And the very last step, we have the margin of error. you take the sample mean, you add the margin of error, and you subtract the margin of error. And that would be your int mean. 5-step process. What would a t-distribution look like? No different from a normal distribution. By all means, they look the same. Numerically, they are different, but in terms of the shape, they are the same. The mean is 0, so 0 would lie right in the middle. When we form a 95% interval, what we mean to say is that there is a 95% probability between that point and that point. Good? So that's what we mean by 95% confidence. Zero is right in the middle, so would that number be positive or negative? Negative. Naturally, the other one has to be positive. So, %95 lies between the negative and the positive critical value. So, what percent would lie on either tail?
2.5%.
2.5%. So that area earlier today, I connected sea level to alpha. So in that case, the very first case, if sea level is 0.95, the confidence level, what is the value of alpha?
Okay,
0, 1. But
0.05.
0.05. 1 minus 0.95.
I was doing it if it was 99, not 95.
So 1 minus 0.95, you get 0.05, yes? So 95% confidence. Would imply that alpha is simply 0.05, yes? Connect the dots. If alpha is 0.05, what is that in terms of alpha?
Okay, 0.25.
That is correct. It is 0.025. But in terms of alpha,
1/2 alpha.
1/2 alpha. I can call this alpha over 2. Yes? How about that side?
The same.
It is the same. There is a reason why I'm doing all this. Hopefully it makes sense to you. The distribution is T, right? That's what we're talking about. It's a T distribution. So here is the notation. T. Subscript. The area below the negative or left critical value. What area do I have? The one shaded in orange.
1/2 alpha.
1/2 alpha. And it requires another term, and that term would be the degrees of freedom. And in this case, it is just n-1. Good? That's the notation. What would the notation be on the other side?
The same thing, but n+1
n+1.
instead of n-1.
Okay, good try. It has to be n-1. That alpha over 2 is the area below the critical value.
So it would be 2 alpha.
Keep trying. So what is the area below the positive critical value? The area above is alpha minus 2. What is the area below? %100% of a candy bar. You took a bite, alpha over 2. How much are you left with? Full candy bar, you ate 2.5%. How much do you have?
1 minus alpha over 2.
1 minus alpha over 2. It's like you've never eaten candy before. Right? If the area above is alpha over 2, the area below is 1 minus alpha over 2. With me so far? Okay. That's just the notation. Now I can just put in the numbers for the first one. So in terms of the value of alpha that I have, T alpha over 2 is 0.025. The degrees of freedom is n-1. So that would be 12. T is at 0.975. The degrees of freedom is n-1, which in this case would be 12. Good. Okay. So, the reason why we did all the notational stuff is because it will tell you as to how you can put things in the calculator. So, T would mean inverse T. And what are the numbers that you need to plug in? 0.025, 12. So press second, bars. If you have a TI-83, just be patient. You probably don't have inverse T. Going to select option number 4. The INVT inverse T would correspond to the T in my notation. I'm going to pick the one on the left hand side, so 0.025. Comma 12. I get negative 2.179. I want you to take a guess as to what that value would be on the right hand side.
Positive 2.179.
Positive 2.179. But if you want to verify, you can use your calculator. Option 4, what should we plug in to get the positive critical value?
0.945.
Good? No?
How do you do it on page 3 though?
Patience.
I don't have them.
We're getting there. Give me a sec. So go to your textbook, ebook, click on N matter. Table A3. And you should see that table. You've got to be careful. This table summarizes only for the values on the right tail and not the left one, which is why drawing something like this is very helpful. What is the area in the right tail in our problem?
0.025.
0.025. So, which column should I pick?
The third from the right.
Third from the right.
0. No. Oh, no. Fourth from the left. So 0.025.
Fourth from the left or fifth from the left?
Count 4 over.
The
It would be the fifth one.
Okay. So 0.025, that would be the area in the right tail. And what is the degrees of freedom in our case? It is 12. So go to the row, let's say it's 12. .179. Yes. So this table is going to give us positive critical values. Whatever you wanted a negative one, we know it's symmetric. If we find the positive value, we can automatically find the negative value. So you don't need to wait.
So for the exam, should we just print that out and bring it?
Yes.
with us? Will that count as one?
No. So that will not count as part of your cheat sheet. So you're welcome to print out. Good? Okay.
So what would our critical value be?
Okay, having something like this, it is useful, but if you can't guess it, that's fine. If you can get it without the picture, I mean. And you'd have to go through a lot of trial and error, but if you draw this, you can get it right away. So the second one, part B. So the confidence level is 0.99. So what is the percent in the middle? 99%. If so, what amount of area do we have on either side? 0.05? 0.005. One person divided by 2. Calculator, 0.01 divided by 2, 0.005. So y 0.01 divided by 2, because in total we have 1% unaccounted for. So you have to take that 1% divided by 2, you get 0.005, which is 0.5%. So in terms of the notation, let's see if we can give me exactly what should go here. T sub
Or 0.005.
0.005, comma 24. On the other side, it would be T sub 1 minus 0.005, which is 0.995, 24. You can pick which one you like. So in your calculator, all you have to do is put in those values like the way you see it. So second, $2.7969. If it is 2.7969 on this side, what would the value be on that side? Negative. If you're going to learn with this particular chart, make sure you stick to this chart. If you Google, I'm sure you'll get different types of T-charts. But some would use the area on the right. Some textbooks would say I'll use the area on the left. So don't look at all these charts and confuse yourself. Just stick to one for the time being when you're learning. So.
Could you post an announcement on Canvas telling us how to find this?
I can just download and put the PDF up, yes. Let's see. Which column should we pick?
0.005.
0.005, and then we've got to go down and find 24. Good, 2.797. Okay. Last case, we have a sea level of 0.9, which would imply what percent would we have right in the middle? 90%. What would the area be on either side? 0.0045.
5%.
5% on either side, right? If you count for 90% in the middle, you're left with 10%. 10% divided by 2 is 5%. So the area here .1/2 is just 0.05. Good. In terms of notation, so what should the notation be over here?
.05.
Good. The other side is a big 0.95, 43. So, if you're using the chart, you've got to be careful about one thing. So, as you can see, after 40, they just got lazy. 40 jumped to 50, 50 to 60, 60 to 80, 80 to 100, 100 to 200, and then they just put the letter Z. Gave up, right? So there is a reason as to why they've listed it this way. If the degrees of freedom gets really, really large, then whether you use inverse T or inverse norm, you get the same answer. And you've got to be really large, so beyond 200, if you use inverse norm, you'll get the answer for any of these cases. But you need a large degree of freedom. What do I mean by that? Give me a large value.
402.
402. Okay. So I'm going to take the last case, which is 0.95. I'm going to plug in 402. I get 1.64865. Now, since the degrees of freedom is large, I'll just do inverse norm and 0.95. Mean 0, standard deviation 1, doesn't matter. Pretty close, right? Off by a tiny bit, but eventually they will just match up. And that value would actually be closer to that value. So that's what we mean by, using a normal. That's why we have that letter Z at the bottom. Good. Any questions? Okay. Okay, so the time an FTC student spends on laundry per week, excluding folding, is analyzed. A sample is collected and it is shown below. Time is in hours, and this is what we got. Mu is the population average. So that would be the average time an FTC student spends on laundry per week in hours. This is for the population. The population in this case would be FGCU students. I can't, go and ask every single student, so I'm going to come up with an interval based on the sample that I collected here. So going back to our 5 steps, the very first step is collecting the sample, which we did. What is the second step? From earlier today, I wrote 5 steps.
Find the mean and standard deviation.
Finding the mean and standard deviation of the sample.
How many samples did we collect?
There's 24 items.
Do we have the mean?
1.927.
We'll call it 1.93. Standard deviation.
0.794.
Did you say N was 24?
Yeah.
Yes.
So using the sample, we found the mean, the standard deviation, of course that's the sample size. What is the next step? Huh?
Confidence level.
Confidence level, so we know the sea level is 0.95. Which would imply alpha is
1 minus 0.95.
1 minus 0.95, which is 0.05. The next step,
The next step is to the margin of error.
the margin of error A is always a product of two things. One is the standard error, which is given by the formula S divided by square root of n. It's 0.1415.
4.6.
Exactly right around.
It's 0.161, so exactly.
We just want the critical value in one of two sides, and typically it's best to have the positive critical value so you don't mess around with signs. The area in the middle is 95%, yes, which would imply the area on either tail is and as a notation over here, it'll be 1 minus 0.025, 0.975, n minus 1, which would be 23. And that's good enough. It's best to have a positive critical value. So what do we get?
Uh, 2.07.
How do we get the margin of error now?
Multiply the two.
Multiply the two together, and what do you get? 0.323.
With 0.3312.
We'll just call it 0.33. Now, when you do the homework or the exam, it's best to have at least 4 decimal places, so you're as accurate as possible. I'm gonna erase that. Save that data for next time. I'm gonna show you an easier way to do this. Now that we have the margin of error, how do we find the interval? Do we know the sample mean? Yes, we do. It is 1.93. Minus the margin of error, which is 0.33. $1.93. Plus 0.33. So if we subtract so that is the 95% confidence interval. Based on the interval that we have here, could we say that it would only take about half an hour for an FTC student to do laundry? No, because based on the sample that we collected, it is very likely to fall between those two values. Even though we had half an hour, we had 0 hours, the true value based on the sample that we have is likely to fall between 1.6 and 2.26. Good? Yes. Yep, that's the stuff. If you have questions, talk to me.